Alrighty, we're going to talk about ionic bonding today. Hopefully you learned a little bit something in our activity that we did with the POGO, but this is just some more concrete notes to go over things. There will be another posted video about how to write ionic bonds as well, a video not made by me, and I would highly suggest you watch both this one and the other one, as naming gets a little bit complicated. So right now we're just focusing on ionic bonds and naming ionic bonds. And remember that ionic bonds are a bond between a metal and a non-metal, and it's generally the complete transfer of electrons. So, some rules for naming ionic compounds. So, of course, your first rule that's not even listed here, before you even start, you need to make sure is an ionic bond. So is it a metal with a non-metal? Is it something from the left side of the staircase with the right side of the staircase? If so, then you know you can follow these rules. So these first rules we're going to talk about is how do we go from a formula to the name. So a formula is something like H2O. That would be the formula, whereas the name would be dihydrogen oxide, which we haven't learned yet, but we just call it water. So the formula is this, like H2O or NaCl or something like this. So the rules for this is you name the cation, which is always the metal, first. So the metal always comes first, and the anion comes second. So if we're looking at NaCl, Na comes first, so sodium comes first, and chlorine comes second. We name the metal, so it's just sodium, Na, sodium. And then notice rule number 3, it says name the anion, but change the ending to "ide." So when we say sodium chloride, we don't say sodium and chlorine. We don't say sodium chlorine, we say sodium chloride. So that's why people often called chlorine chloride, because when you're naming them together, you have to change the ending to the IDE. So let's do some practice problems together with these rules in mind. So BaS. So Ba is barium and S is sulfur. So it's not going to be barium sulfur, it's going to be barium sulfide. Okay, barium sulfide. Go ahead and try these next two on your own, and then we'll go over them together. So go ahead and pause the video a moment. Okay, that second one, K2O. K is potassium, and hopefully you remember this from first unit when we learned all of those elements. And O is oxygen, so it's potassium oxide. Not potassium oxygen, we have to change that ending to the IDE. And then lastly, hopefully you figured out that the third one is magnesium nitride. Notice, remember, from our last lesson that the 2 and the 3 are switching because those are the associated charges. Okay, so it's pretty easy to name ionic compounds when we're given the formula. It gets a little bit trickier when we're given the name and have to find the formula. So, we're first going to name the element. We have to identify the charges. Okay, so we're going to figure out what two elements are we dealing with, what are our two charges. We're going to swap our charges and then ensure the overall charge is 0. That is always the goal. So to do some of these practice problems, I am going to go to the whiteboard in the back. Our first one we're going to look at is sodium bromide. So for sodium bromide, like our rules say, our first step is to name the elements. So we have sodium, and bromide is bromine. Bromine or bromine. Okay. Our second step is to identify the charges. So remember back to our last lesson, sodium has a charge of Na plus 1 because it's in that first column, whereas bromine has a charge of Br minus 1 because it's in that almost final column. We're going to swap our charges, so our 1 and our 1, giving us Na1, Br1, and we know that those charges will cancel out, so we're left with NaBr as our answer. And we know that overall charge is 0 because a negative 1 plus a positive 1 gives us a charge of 0. Our next one we're going to go over is beryllium chloride. So beryllium chloride, we know we have beryllium, Be, and chlorine, Cl. Beryllium has a charge of plus 2, whereas chlorine has a charge of negative 1. So these charges aren't equal, so we can't just leave them blank. So we need to swap them. So that's our first method. We can swap them to give us an answer of BeCl2. Or you can use the boxing method. So remember, if we have beryllium, it has a positive 2 charge. Okay? Whereas chlorine only has 1 -1 charge. So we can cancel these negatives, positives and negatives, but we need to add 1 more chlorine so we can cancel these out. So we're left with 1 box for beryllium and 2 for chlorine to give us an answer of BeCl2. Our last example for this one we're going to go over is lithium sulfide. So we have lithium and sulfur. We know that lithium has a +1 charge, whereas sulfur has what charge? Go to -2, so we're left with Li2S because we're swapping the charges. I want to show you that box method one more time just to see, just in case you're confused. So Li has a +1 charge, whereas sulfur has 1 -2 charge, so 1 box with 2 negatives. We need to add 1 more +1 box so that we can cancel everything, leaving sulfur with 1 box and lithium with 2 to give us Li2S. Things are going to get a little bit trickier here when we start talking about compounds that don't always have a charge, so those transition elements. So looking at transition elements, the first thing we're going to have to do is practice our Roman numerals. So hopefully you remember Roman numerals. Hopefully you learned these at some point in your education. The Roman numeral 1 is just an L. So that's 1. 2 is 2 lines. 3 lines is 3. And then 4 is where it gets a little bit different. So this represents a 5. And if you put the 1 before it, it represents 4. So a 5 is just a V. And then if you have V1, so the line after it, it represents 6. And then V2 is 7 and V3 is 8, of course. Okay, so you're going to have to know those when we're talking about ionic compounds with more than 1 charge. So some rules for ionic compounds with more than 1 charge. The metal, of course, is always going to go first still, and the nonmetal is going to go second. And there's still going to be an IDE ending, but things are going to be switched up just a little bit. So let's look at some practice ones. COCl3. So CO is cobalt. Okay, cobalt is in the middle. It's a transition element. So we don't know what the charge of cobalt is technically based on our rules we have. But if you look at cobalt on the periodic table, see it's in the middle. It's right here. Sorry, I'm doing this backwards, so I can't find it right away. It's right here. Okay, it's in the middle. According to our rules, it doesn't have a set number of valence electrons. But if we look here on our given COCl3, where did this number 3 came from? It came from cobalt. So it's telling us that cobalt has a charge of 3. So to name this, however, we're not just going to call it cobalt chloride because it doesn't denote that the charge is 3. Instead, we would name it cobalt. I should have typed this instead of writing it with this trash pen. Cobalt 3 chloride. Because we don't know what the charge of cobalt is, so we have to tell everybody what it is. Okay, so it's cobalt 3 chloride. And notice we're still changing that N to the IDE. The next one is nickel 3 iodide. So to solve these, we have nickel, and it's telling us it has a charge of +3. We have iodine, which we know iodine has a charge of -1. So just like before, we're going to swap these guys so that we have a final answer of NiI3. This is when it becomes very important that you use your uppercase and lowercase letters to denote that nickel and iodine are separate. For this last one, we have SnF4. Sn represents tin. So we're going to have tin 4 fluoride. Now, if you got confused during this part, make sure you reach out. If you got confused about any of it, make sure you reach out, but especially this part because this is the toughest part to understand. I think those are actually all our notes for today. So next class we're going to be looking at naming molecular compounds or covalent compounds, but let me know if you have any questions on this. Thank you.